Have been invited because you have some connection to Cameron. You may or may not understand all of the technical parts of his presentation, but it's a requirement of CIS for him to give this, and he'll explain that. So we're going to just turn it over to Cameron Moeller, our presenter for today, and let him begin.
Well, hello everyone. First of all, I want to thank everybody for coming. This is my senior project presentation, and before I get into what my presentation or project was about, I'd like to describe a little bit about the senior project. The senior project is a class required for CIS students to graduate from HLG, and the project is an opportunity for the students to choose a subject that they're interested in and work more on it. And well, there are two paths that you can take when choosing a project. One is if you know what you'd like to do in your future career, then you will choose a subject that you are interested in going into and learning more about it. Or if you don't know what you want to go into, just like me, then you will choose a project that you would like to just learn more about. And yeah, so the projects are usually designed to help people if applicable. And the project consists of 3 parts. The work, which can be 40, 80, or 100 hours, and that depends on how many credits you need the class to count for. The second part is the technical paper, which is a manual or a step-by-step process of what you went through to finish the project, and the professional presentation as I'm giving right now. Now, originally, when I decided to take the senior project, I chose that I wanted to try to develop an iOS application, and as I started to go through that, I realized that it would take a lot longer than a semester really to do, and I realized I wasn't really that interested in it as I thought I was before. So in the beginning of the semester, I talked with my professors, and we decided that I could do a project related to digital forensics. And for those of you who don't know, digital forensics is a branch of forensic science that specializes in the investigation and recovery on digital media. My project consisted of 3 main parts. The first part was Windows password recovery on a laptop. The second part was the recovery of images and a browser-saved Hotmail password off of a corrupt hard drive, and the recovery of any information possible on another corrupt hard drive. The first part of my project was the Windows password recovery, and one of my professors gave me a laptop. This isn't the exact laptop, but I'm just using it for this presentation because I already gave it back. And the owner of the laptop forgot their Windows password, so I needed to figure out how to recover that password with forensic tools. Now, some of you may be wondering why I didn't just use Microsoft tools to reset the password and it would be that easy. Well, in a digital forensic environment, if this was part of evidence, I wouldn't be able to do that because if I reset the password to get into evidence, that would be considered tampering with evidence, and I wouldn't be able to do that. So my steps to getting the password off of the machine was installing an operating system on a USB drive and using that USB drive to boot to that operating system and use the tools on that operating system. If that sounded a little confusing, I'm about to describe it. Now, the operating system that I used to put on this USB drive was called Kali Linux. Kali Linux is an operating system just like Windows 7, Windows 8, Mac OS, and Linux is different because it is an open source tool, and what that means is that people can change the source code to whatever they want to use it for. So someone created Kali Linux, and it was perfect for what my project consisted of because it is specifically for digital forensics and penetration testing. It includes a lot of built-in tools that will help with many different security tasks. After installing the operating system on the USB drive and booting to it, I needed to research how Windows passwords were stored. So Windows passwords store their passwords as hash values. Hash values are basically an encrypted version of your password, and they're stored on the security account manager, which is just a file hidden in your hard drive. Now, an example of a hash value, if your password was password123, then this would be the hash value that is in the SAM file on your computer. And the tool I used within Kali Linux is called offcrack. Offcrack is a tool that, if you point in the direction of the SAM file that has all of your passwords, it will find the hash values of the users, and then it will use what is called rainbow tables to decrypt that password. Rainbow tables are tables that are created by other people, and they use the encryption key that Windows uses, and it basically reverse engineers the password, so it will print it right here. Now, when I was using offcrack, I was able to find the hash values of the user accounts, but the rainbow tables in offcrack weren't working for me, so I had to find a decryption tool online and copy the hash value, and I found the password like that. This leads me to my second part of my project, which was the recovery of images and a stored Hotmail password off of a corrupt hard drive. This was the machine that had the corrupt hard drive, totally separate from the laptop I just talked about. And my professor gave me this machine, and it had, the owner wanted any images that could be recovered off of there, and they also needed a browser-saved Hotmail password that they had forgotten recovered off of here. The first thing that I needed to do, or needed to focus on with this machine, was recovering the images off of the hard drive. Now, before I could even work on the hard drive, I had to make sure that I cloned the hard drive or made a copy of it. This was imperative because, as I mentioned before, when working on evidence, if I was treating this as a digital forensics investigation, I could not make any changes to this machine, or else it would be considered tampering with evidence. So I had to make a copy, and this was the clone drive that I used. And cloning a hard drive can be done many ways, but I used Kali Linux and used a terminal command within it. And for those of you who don't know, the terminal is the Linux equivalent to Windows command line, which many of you may have seen before. You can use a bunch of different commands to make a lot of changes to your machine. So after the clone was created, I used a tool on Kali Linux called Foremost. Foremost is a tool that you can execute through the terminal, which I just showed, and Foremost searches through all the files on your hard drive and looks for a specified file type that you want to look for. And when I ran the command, it's hard to see up here, but the command that I ran looked for all the image files, which are the most common, such as the JPEG, PNG, and GIF files. And I ran the Foremost tool, and it gave me all of the images that were not corrupt on that hard drive. Now, the second part of working on this machine was recovering the browser-saved Hotmail password. The owner of the machine used Hotmail on this machine, but when they would log in, they would just have the browser save their password, so they wouldn't remember their password. When the machine crashed, they had no idea what their password was. So my job was to go in there and try to find it. First, I had to figure out how Firefox stored the passwords, because Firefox was most likely the browser that was being used. Firefox stores passwords within two files. One is a text file called signons.txt that stores an encrypted version of the passwords, and the other file that Firefox uses is a key.db file, which is the encryption key, and both of those used together, Firefox is able to reconstruct your password and give it to you when you need to use it. Both of these files are found in the following directory. Now, to find that directory on the clone hard drive, I had to use a cool tool called Autopsy. Autopsy is a tool that you can, this is a screenshot of it, it's a tool that you can plug in a disk image, and you'll be able to sift through all the directories and the files. The problem was when I plugged in the clone hard drive, I realized that the directories and files that were there were not those of a normal hard drive. There was a bunch of bad sectors or sections of the hard drive. And so I concluded that I would not be able to find the Hotmail password because it was most likely in the corrupt data. This leads me to my third part of the project, which was the data recovery off of this separate machine. My professor also gave me this machine, and it had a corrupt hard drive. But the problem with this hard drive was that it was way more corrupt than the other one, and when you boot it up, nothing came up and it couldn't read anything. Also, the hard drive would spin, but it would have a distinct beeping noise. The beeping noise usually indicates an error, and in this case, I thought it would be a circuit board error. Now, replacing a circuit board of a hard drive is possible, but it's incredibly tedious and difficult. As you can see on this picture, the green part right here is the circuit board, and in order to replace it, you need to find a hard drive that is basically an exact match with the same model and series number. Now, I wasn't able to complete this part of the project because I did not have the resources available to me, but if the circuit board was a match and I found one and I replaced it, then there was a possibility that I would be able to read the data on there. There was also a possibility that the circuit board wouldn't even fix anything and the hard drive would have just been crashed. So in conclusion, I talked about in part one how I used Kali Linux and Offcrack to recover a Windows password. In part two, I talked about using the Foremost tool to recover images off of the hard drive. I also talked about using Autopsy to figure out that the email password recovery was not possible. And in part three, I researched on how to replace a circuit board on a corrupt hard drive. This concludes my presentation, and are there any questions?
At this part of the presentation, we encourage questions from the audience. All questions are fair game, maybe about the project or about his experience.
I've got one for Cameron.
Yes.
Do you plan to work for the FBI after this?
That would be awesome. I'd love to. That'd be
That's supposed to be a joke.
nice.
Not your work for
I'd
the
take
FBI.
it.
For the political
I'll
season,
take it
anyway.
seriously.
No, I would love for you to see you do that. I'm just saying, for the political season, that was supposed to be.
How successful were you on the image recovery?
I can't really say for sure. I know that actually most of the hard drive was corrupt. So in the images that I did find, I sifted through some of them, and most of the images you'll find will be small files that come in the applications that you download. They'll just be stock images. But I also found other images of people that may be the images that we were looking for. I can't say for sure. When I give them to the owner, they'll be able to say. So I'm not completely sure.
But you were able to retrieve images
I
to
was
get back.
able to retrieve images, and I'm happy about that. So
How much knowledge did you have before you started this project?
absolutely none. I did not know anything about digital forensics. So all of the tools that I explained and Kali Linux is all new to me. I spent probably most of my project hours researching because I needed to know exactly what I was doing. So
How many project hours would that be?
42.
And because students have an option of a 40-hour project, an 80 or 120-hour projects, 1, 2, or 3 credit hours, if you had an 80 or 120 hour project, you could have done some more things, but what we asked
Yeah.
you to do, your 40 hours have been filled up accomplishing what you did. And we also didn't want to have to try to start buying circuit boards to give him those options. And he did what he was supposed to do in the time that was allowed, and then the project was done.
Cameron, is this an area that one can specialize and get into, or is it something that you do in addition to being hired
Yeah,
in the field?
digital forensics is a whole section of, well, maybe not small police departments or small agencies, but there are definitely digital forensic specialists and teams. Now, those digital forensic specialists may specialize even more in data recovery, or there's just a bunch of different sections that digital forensics can go, and there's most likely just specialized people for each job in digital forensics. So there are digital forensic examiners in most agencies. Yeah.
And did this project maybe steer you in that direction, or is that something that you thought about?
Yeah, I've thought about it. It made me think about it more because I'm very interested in it. And what sparked me to actually get in this project was I started class this semester in Dr. Nelson's computer security and forensic class, and I was very interested. I started reading the book, and that's why I decided to actually change my project. So,
Is this kind of, not a forensics project, but a senior project you alluded to, you thought it was a good experience? Should every computer student have to do something like this?
yeah, definitely.
And is 40 hours enough, or should they be challenged to do more?
Well, if you can get the project done in 40 hours, I think it's enough. But it'd be good probably to do more. I thought it was a good experience because I learned, as I said before, absolutely everything that I've talked about today. So, yeah.
You told a little bit about the nature of the projects that we assign or help students to select, but for those who are new to this process, I just would say that when we're looking for projects for the students, these are some of our priorities. We would either like to find something that the students have a special interest in and maybe want to make a career, you mentioned that, and something that could help develop their skills even further than what they've done in class already, or find something that they don't know about that might broaden their skill set as well, which is Cameron's case. We also try to find projects that are practical. If there's a real world need on campus, off campus, if we're aware, these are actual real people that had crashed hard drives, and one person had didn't know how to log on to their own laptop and all, and ask us for help. And Mrs. Todd and I get asked a lot to help, and when we can make that a student project, that's all the better, right? A student learns, and somebody in the community gets helped, and sometimes it's on-campus personnel, but if we can make it a real project, that's always our first priority. Sometimes we have to generate a scenario or something for a student just to have the practice, but when we can, we try to help real people. Those are two actual machines, like you said, the laptop we've already returned to the owner, but real problems solved, Cameron solved some of them in the 40 hours that he had to work on it.
I forgot to give you this at the beginning, but I'd like for you to show briefly your technical paper and what that kind of involved so they get a better understanding.
Well, as I mentioned before in my beginning slide, the senior project students have to fill out have to create a technical paper, which is basically, most of it consists of a step-to-step process of what I went through with screenshots and explanations, and the rest of the technical paper has the resources that I used, all the tools that I used. I used more tools than I explained today, but they didn't end up working, so I didn't include them in the presentation. It also has a self-evaluation form, a log of all my hours, and also at the end it includes a resume, a one-page resume.
And it's our goal that it's well-written enough that if we wanted someone to follow suit, they should be able to take that document and at least get a jump start onto another project that's very similar. That's our intention.
Cameron, I had another question too. You mentioned the legal aspects of this, that you couldn't do certain things. I'm assuming that's in a police context or a law enforcement context?
Yeah, that would be in a sense if I had recovered this laptop at a crime scene and I was assuming that there was evidence on here. If I couldn't get into the machine, I couldn't just wipe out the password and get right into it. I would have to use tools to jump around it and basically go in a back door like I did.
Okay, and are there other legal limits though to doing digital forensics that you are aware of? That would limit what kinds of things you can do?
I'm not aware of many
Okay.
others, I'm sure there are.
Okay.
So there's a lot of guidelines. And
Well, I think you do know some, like Wireshark, you should not be snooping without making sure that the people that you know, you can listen in on wireless signals, and there are easy tools to use that, but you should not do that without informing the folks that you're running a test or whatever, which is why it's dangerous to sit in McDonald's and check your bank account, because you have no idea who's sitting in the next booth, and open wireless and things like that. But, you know, I think it's more about notification, and, I mean, can't speak to all the FBI rules, but if you were just learning, we try to be very explicit about what we're doing so that we're not spying on anyone or putting anything at risk is really what we have to be aware of, in my understanding. Dr. Nelson, you're the security teacher. Do you have anything to add to that?
No, I mean, the main thing is when you go to defend your analysis, one of the things you have to do is demonstrate that you didn't make any changes. And it's awfully hard to work on any electronic digital device and not be making changes. In class, one of the things we learned about, something as simple, there is a solution to it, but when cell phones first began to be a need for those to be collected in investigations, there was a dilemma. Do you take the battery out so that you don't make any changes? Like when you pass cell towers, you carry the phone from the site where it was collected and you carry it to the police station, you pass new cell towers along the way. It's constantly updating what was the most recent cell tower it's been passed. And so you're wiping out older data about where that phone has been if you leave the battery in. But if you take the battery out, then certain stuff that was saved would be lost. And so there were real dilemmas. How do you decide which data you're most interested in trying to preserve? Of course, the solution to that's what's called a Faraday bag, and you can put the phone inside a special wired bag that doesn't allow signals in or out. And so you leave the battery in, put the phone in the Faraday bag, and you can take it wherever you want, and it's not going to contact cell towers and update stuff. But that kind of dilemma with computers, you take a machine, you unplug it to take it back to the lab, or whatever was in what's called volatile memory, like RAM, is likely going to be lost. When you unplug it, that disappears. I mean, there are ways even to get around that, but which we learned today, right? What do? Freeze the machine down to 58 degrees below zero before you unplug. I mean, there's a Hannibal Police Department's not going to be doing that. FBI can do that if it's a big enough investigation. What tools are brought to bear depends on how big a profile case it is.
That's all you gotta do. We were telling a joke. We said, if you gotta freeze the machine, just put it in the ad building. It's always cold over there. Cameron, I don't want to put you on the spot. I think you know everyone in the room fairly well, but and not everyone here knows everyone. Can you tell us their connection? We can say our names so we don't put you on the spot, but between you and the person, that tell them why they're, what the connection you have to these individuals. So I think you know the first gentleman.
Dr. Nelson, he's my professor in some of my classes, or most of my classes.
Mm-hmm. Can you work your way around? If you get stuck, we'll help you.
This is Gary, and he is the OCS, just the director of OCS.
Everyone doesn't know what OCS is.
Oh, Office of Computer Services. And last year I had to do an internship in the Office of Computer Services as my internal internship. And so I was working under Gary. This is Zulma. This is my classmate. She is in most of my classes as well. This is Henry Sweets, and he is the director of the Mark Twain Boyhood Home and Museum. It's such a mouthful. And he is my supervisor's boss, and he came to watch today. This is Brian, and he is now working in the Office of Computer Services as well. And yeah, he just came. Earlier in the year, I had a problem with the WordPress site, and I went to Brian, met him, and he helped me out with it. This is Dr. Dennis, and well, I know Dr. Dennis. She's Mrs. Todd's sister.
Well, that's your claim to fame.
She's a professor here, of course, as well.
It's okay to say that We also have an apartment in our basement.
Yes, and I live
Cameron lives in our
with
basement.
Austin. That's
With
my
Austin.
roommate. That is Jeremy. He is also one of my classmates, and he's in some of my classes. This is Justin. He is, well, used to be my classmate in some of my classes. He was also my boss in the Office of Computer Services when I was interning there, so that was pretty cool. Having a class with him and being my boss.
Pretty cool.
This is Mrs. Todd. I'm sure all of you know Mrs. Todd. She is my professor and the director of CIS. There you go. That was,
That's good.
this is
Yeah,
Nathan
this is your
Davis.
degree, remember?
I'll get the paper, I can read it.
Okay.
This is Nathan. He is, well, was on my volleyball team. There's no volleyball team anymore. This is Austin. He was also on my volleyball team, and he is my roommate. This is Dr. Swisher, and I used to have class with him. He is a history professor. This is Anthony. He used to be my volleyball teammate as well. Now we're just friends, I guess. And this is Melissa, and she is my current supervisor at, and she works at the Mark Twain Boyhood Home and Museum. That's everyone.
Thank you, everyone, for coming.
Yes,
Yeah.
thank you for coming.
Well, that will conclude, I think, unless you have any other questions. We would ask if you can fill out an evaluation form on him and give him some valuable feedback. Take time to write a comment or two in certain locations. We're among friends. He will take it well. We grade the project. We grade other parts of the, you're mostly grading presentation and what you thought you observed and learned from his presentation. And then if you could leave that for me, that would be appreciated. We thank you very much for coming, and I think that would be it. Cameron will, you're welcome. Well, thank you. You're welcome to leave at your discretion, but Cameron might want to meet them at the door and shake hands or whatever as they leave.